Okay, so we have the review for this unit. You already have all the questions for the review. We're going to go over the first FRQ towards the end of the review, or the second, on the second page there, number 14. It gives you the graph of the function f is given. So over here we have these two lines, and it says it consists of two lines, such that g is given by this. I'm going to write this down because this is important. G of x is equal to the integral from 0 to x of f of t dt. Okay, so that's the relationship here. So we're probably, throughout this problem, going to be referring to or asking about the value of g. And we find the values of g by comparing g to the function f. So in part A, it says, what is g of negative 1? Well, notice that the variable x is being replaced with negative 1, so we're going to do the same thing here. We're going to plug in negative 1 to the variable. So you get 0, the integral from 0 to negative 1 of f of t dt. And so we just have to evaluate that. Now we have, in our picture, we have lines. So essentially we have triangles and trapezoids, however you want to look at that. We're looking for the integral from 0 to 1. So we're going to look at this as a graphical approach. And if you think of integrals, it is finding the net area. Okay? But notice we're going from 0 to negative 1. We're going backwards. So another one way of looking at this is saying, okay, from 0 to negative 1, I notice that it's a triangle. So it's 1/2 base times height. The base is the distance of the interval. Well, in this case, the interval is going from 0 to negative 1, so it's going back. So the base length is 1, but it's in the negative direction. So we're going to put a negative 1 for the base. And the height over that interval for that triangle is going to be 3. And it's a positive 3 because it's above the x-axis. And we can simplify this as negative 3/2. Another way to look at that, if you need to, is to rewrite this integral by flipping the bounds. So we could have said negative integral from negative 1 to 0. That way we're reading it from left to right. Makes it maybe a little bit easier for some. So it's the negative area from negative 1 to 0. So it's be 1/2 of the base. The base is the distance from negative 1 to 0. But this time we're heading to the right, so it's going to be a positive 1. And the height is still positive 3, but ultimately we end up with negative 3/2. It's just a different way of looking at it if you need to. Okay? So that is g of negative 1. Okay. Now we want g prime of negative 1. Well, before we can take g prime of negative 1, we have to take g prime of x. And this is dealing with the fundamental theorem of calculus. If I'm going to take the derivative of g, well, just like in algebra, whatever I do to one side, I've got to do to the other. So I've got to take the derivative of this guy. Well, the derivative of an integral, fundamental theorem of calculus, is essentially the integrand. The derivative and the integral cancel each other out, but you have to be careful to apply the chain rule. Since the bottom number is a constant, and the upper number is either a variable or a function, we can just take the derivative of the integral by saying g prime of x is equal to f, it's the integrand, so it's f of, instead of t, we're going to plug in our upper limit, so it becomes f of x, and then we have to be careful that we multiply it by the derivative of what's inside our function. So the derivative of x is just 1. Okay? And I know that seems silly or overemphasized, but if that was an x squared or any other function there other than x, you'd have to multiply it by the derivative of that function. So in the case of x squared, you have to multiply by 2x. But in this case, f prime is just equal to, or g prime is just equal to f. So now we can evaluate g prime of negative 1. So that would be the same as f of negative 1. And because we were given the graph of f, we just have to observe what f of negative 1 is. And it is 0. So g prime of negative 1 is 0. So that's that one. And the last part is g double prime. So we have to evaluate g double prime of x. Well, if g prime of x is equal to f of x, then g double prime of x is equal to f prime of x. So then g double prime of negative 1 is equal to f prime of negative 1. And the way to interpret that is to say, what is the slope of the tangent line of f at negative 1? Well, if we go to negative 1, we can see that it's a constant line, so we can actually evaluate that slope. If it was curvy, we couldn't evaluate that slope unless it was a 0 value. But the slope is going to be whatever the rise over the run is. So we can see that on both sides we're rising 3 and running 1, so the slope there would be 3. So g double prime of negative 1 is 3. Okay, so that's part A. And generally that's going to be 3 points. You're going to get 1 point for each one. Part B says for what values of x from -2 to 2 is g increasing? So we're going to justify it before we go to answer it. We're going to say g is increasing. G is increasing when g prime, if you think of the chart that we've talked about, g prime of x is positive. G is increasing when g prime is positive. But we weren't given g, we were given f. So we have to relate g to f. Well, the relationship here is we want g prime here to be positive. If we go back to part A, we knew that g prime is equal to f. So I'm going to write that down. G is increasing when g prime, which equals f of x, is positive. Or we could say greater than 0, greater than or equal to 0. So where can we see that f, the graph of f was given, where can we see that that is positive? We can see, therefore, that it's above the x-axis from -1, less than or equal to x, less than or equal to 1. Okay? Now it's inclusive. It's the closed intervals. We want to include -1 and 1 on any increasing or decreasing answer. If it was concavity, we want open intervals. Okay? And that's, I believe, what we're talking about in part C. It says, when is g concave down? Well, let's interpret it. G is concave down, thinking of our chart, g is concave down when g double prime of x is negative. G is concave down when g double prime is negative. Well, g double prime is equal to, right here, g double prime is equal to f prime of x. So g is concave down when g double prime of x, which equals f prime of x, is negative. Well, here's the problem. We were not given f prime. We were given, in the graph, we were given f. So we have to interpret this in terms of f. F prime is negative when f is decreasing. That's why that chart is so important, okay? So when is f decreasing? F is decreasing when the function is heading downward. So we would say from 0 to 2. Okay? And again, it's open interval. It's not inclusive because we're talking about concavity here. Okay, so that's part B and part C. Let's see, 3. These are going to be probably 2 points each. 1 for the correct answer, 1 for the correct justification, 1 for the correct answer, 1 for the correct justification. So that's part C. Part D, it says to graph G. Well, graphing G. We want to graph G. G is the integral of f, or another way to express that is that G is the antiderivative of f. Or another way to say that is that G, like we said before, G prime is equal to f. So f is essentially the derivative function of G. Well, the first thing I know is I have some values that I know. I know that G of -1 is -3/2. So let me get this chart down here. We got -1, -2, -1, -2. We go up 1 and 2. So this tells you the graph isn't too difficult to do. So at G of -1, we have a value of -3/2. Let me use a different color here. So if I go back 1, I've got to go down to -3/2. And we know at -1, G prime is 0, so we have kind of like a flat line there. So we can do that. And some other critical points that might be of value that we want to consider. We do know that G double prime at -1 is positive, so we know that this function is concave up right here. Okay, so we know it's actually a minimum because it's also 0. But where else, this is a good question to ask, where else is G, or where is G equal to 0? If we go back to our original equation, G is equal to the integral from 0 to x of f of t dt. Where will G be equal to 0? Where will it pass through the x-axis? Well, one place is when x is equal to 0, because the integral from 0 to 0 is 0. So when x equals 0, G equals 0. That's one important point. Where else will we possibly get values of G being 0? Well, if we look, if we look at the original function, G is equal to the integral from 0 to x. That means from 0 to whatever, okay, from 0 to what will give you 0? Well, the integral from 0 to 1 is going to be 3/2 if we do that. But the integral from 1 to 2 is -3/2. So the integral from 0 to 2 is going to cancel out the area, so you're going to get 0. So that means if the upper bound of our integral was 2, the integral from 0 to 2 is 0. So when x is 2, g is going to be 0. So we can express that here. Okay? And again, from 0 to 1, we got 3/2, so we can express that there. So you can kind of get an idea of what's going on here. Now, if we go backwards, is there any other place where g would equal 0? Well, at -2, if I plug in -2 to this, the integral from 0 to -2 would be 0 also, because we have an area of a triangle here, and the area of this triangle are the same thing. So at -2, we also have a 0. So you can kind of see what's going on here. The other way to consider this, and this is important, is that since this is a line, when I go to take the antiderivative, I end up with a parabola. Okay? So I'm going to have a parabola on this side, and I'm going to have a parabola on this side. And you can kind of see the parabolas taking shape. It's going to look something like this, okay? And then it's going to look something like this. Now this looks like the sine wave, but it's not, because these are two parabolas, okay? But that is the graph for D. You're going to get 2 points for this. You're going to get 1 point for basically identifying the zeros, and then 1 point for the correct curve. So a total of 9 points on that. Number 15, yeah? Okay. So a tank contains 125 gallons of heating oil at T equals 0. That statement is called a what? There's something, though. It's an initial condition. It tells you how much you start with, right? So keep that in mind. During the interval 0 to 12 hours, heating oil is pumped into the tank at a rate of h of t. That's huge, right? So h of t is the rate what? It's the rate going into the tank, right? And in this case, it says r of t is the rate at which oil is leaving. So that's the rate out. So you have the rate in and the rate out, okay? So we have that going on for us. And it says how many gallons of heating oil are pumped into the tank during the time interval 0 to 12. So if I want to know how many gallons are going in, do I care about how much I started with? No, I only care about how much goes in. So is the question asking for a rate or for an amount? It's asking for an amount. What did I give you? I gave you rate. So how do you go from rate to amount? So we're going to go the integral from 0 to 12, because it says over the interval 0 to 12, of h of t. Is that it?
No, minus d.
It's not going to be minus, because h of t is the rate in, and it just wants to know how much went in. It didn't ask anything about how much changed. It's just how much went in. So that's it there. What do you guys get for an answer? 70? What? 70 point, come on, help me out, guys. 7 what? 571? Well, I heard, we agree? Yes, no? What's the units on this? Gallons. Does it say to round it all? No. Okay, so as you go through this, if you legitimately did this, granted, these are old FRQs, so you can find some of them online, but if you legitimately did this, score yourself and see how you did. Okay? So, part A. Let's see. Can I do this? It's going to let me do it. Part A was worth 2 points. 1 for the integral, 1 for the reason. Or 1 for the integral, 1 for the answer. So if you have this equation right, that's 1 point. If you have that answer right, that's the second point. Okay? 2 points. All right, what about B? Let's see what B says. A was pretty easy, yeah? I think, I hope. Is the level of heating oil in the tank rising or falling at T equals 6? Is it asking for a rate or an amount?
You need to have to exposit with it.
Okay, but what's it asking for? It's asking for if the level is rising or falling. There's the connection there, but it's asking for is the amount going up or going down, right? What's another way of saying that? Is the amount increasing or decreasing? How do you find out if the amount of oil is increasing or decreasing? When its rate is positive or negative. But are we talking about strictly the rate in or the rate out? It's a combination of both, right? If the rate in, let's say, is 10 and the rate out is 7, what's the overall rate? We should have units. 10, whatever, gallons per... Okay, if the rate in is 10 gallons per minute and the rate out is 7 gallons per minute, what's the overall rate? 3 gallons per minute, which means the amount of oil is increasing because there's more going in than going out, right? Or it's entering quicker than it's exiting. So how am I going to evaluate this at t equals 6?
H of 6 minus R of 6.
Okay, so we're looking at rates. H of 6, there's a couple ways of doing this. H of 6 minus R of 6 is what? What is it?
Oh, negative 2.924.
924? Okay. So what can we say? What does H represent? The rate in minus the rate out is negative. Therefore, the overall rate is negative. Therefore, the amount is decreasing. So we would say the oil, the level.
Well, is that because, like, in the case of when oil is being removed, it's just going to be negative because it's going out?
I'm not following the way you said
So
that.
if oil is being removed from the tank,
Yeah.
that can be in a positive rate, or is that, like...
Yeah, well, it's always going to be. Because if it gives you a separate equation, like R in this case is a separate equation going out, that is always going to be positive. If it's negative, then that equation implies there are places where the rate out is negative, which would mean they're going in, right? So you have oil going in from this side and oil going in from this side, which I don't see them giving you a problem like that. You have to compare both of them to determine if the overall is positive or negative. So the level of oil is what? What's the words they used? Is falling. Since
The overall rate.
H of 6 minus R of 6 is negative, right? Say it again. Well, H of 6 is the rate in. R of 6 is the rate out. Therefore, H minus R is the overall rate. It's the overall rate of change. Okay. Did anybody explain it a little bit differently or do something different and still come up with the same type of thing? Nobody? You could have said something like this. H of 6 equals this. R of 6 equals this. And then what would you observe about these two numbers?
H6 is
You would probably see R of 6 is greater than H of 6. Therefore, the rate out is more than the rate in, right? So if you explain it that way, that works too.
That could even be a question, too, right?
Well, that would be the same question. Yeah. Okay? Are we good with that? Let's see what that point looked like. Answer with reason. That's it. Sorry. 1 point. Okay. Number C, part C. How many gallons of heating oil are in the tank? So, what do I have to include in this one? The initial condition. And it does say how many gallons of oil are in the tank, so we have to take an integral of a rate, right? So, what would the equation be for this? The integral from 0 to 12 of what? H of t. Oops. H of t dt minus the integral from 0 to 12 of R of t dt. And then we'll add the 125 to it. Are you guys okay with that? That's one way of saying it. Okay? So this is how many gallons we started with. Remember, H is a rate, so its integral is an amount. So if this is the rate in, then the integral is the amount that went in. R is the rate out, so therefore its integral is the amount out. So we start with this, We add this, we take away that. Does that make sense?
Yeah.
What do you guys get?
122.026.
122 point what?
026
026
gallons.
gallons. Did anybody write that differently? There's different ways to write that equation. Not very many different ways, I guess. Because this is a difference, and because these limits are the same, how else could I have written that? H of t minus r of t, and then dt. And then we still have the 125. What happens if what? In most cases like this, they would consider it a grammar error. So they're not going to ding you for it. But there are cases within other contexts of calculus where if you don't, it might be 5 points of your problem. You know, part C, it might be 5 points. You get 0 out of 5 because you forgot that. Okay? Because dt means something very specific in another problem that we'll get to in the future. Okay?
Oh, we're not there yet.
We're not there yet. But anytime you have an integral, you have dt or dx or whatever the variable is, right? So don't forget it. That way, they won't knock you off on any of the problems. All right, I assume, yeah, this one's worth a lot. You get 1 point for the correct limits. So watch this. If you said the integral from 0 to 12 of h of t dt, and that's all you did, you would get 1 point for the correct limits. Okay? And then 1 point for the correct integrand. So if you separated it like this, or if you look at theirs, they put h of t minus r of t in the integrand as a whole, then that's 1 point. And then 1 point for the answer because that also would include your initial condition. They do. It's nice. So this was what, 3 points here? All right, part D. At what time is the volume of heating oil in the tank the least? What am I asking for? I'm looking for a minimum. I'm looking for the minimum of what, though? That's the key. If I'm asking for the least amount of gallons in the tank, I'm looking for the minimum volume. If I'm looking for the minimum volume, how do I find the minimum of a volume? Take the derivative of the volume, which is what was given, right? Because the derivative of the volume is the rate. You get what I'm saying? Okay. So how would I normally find that? I would say I want the minimum volume, therefore I need to take the derivative of that function. Those were already given, right? So we would say, I mean, I guess you could label A of t. A of t, don't write this down, I'm just giving you an idea. Represents the amount of oil, I guess. So therefore we would say A prime of t is the rate of oil. What would that equation be? A prime of t. In what we can. Say it again. H of t minus R of t. Are you guys okay with this? Okay. So this is the amount of oil. The rate, A prime, is equal to the rate in minus the rate out. Okay. Now you don't have to label all of it that way. What are we going to do with the derivative, though, once we find it? Set it equal to 0. So you would say 0 equals h of t minus r of t. Then what? Okay, well, there's a couple different ways to look at this. You could type this into your y list. Type in 2 plus blah, 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 minus 12 sine blah, 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 right? And that would give you this equation, right? And then you would look for the what? Zeros. Or if you're going to solve it this way, you would add r of t to both sides. So you're looking for when r of t equals h of t, which means you're finding what? The intersection of those two equations, right? And only over the interval what? 0 to 12 in this case. So you don't have to label all of this. So I'll get rid of it. You can have it there as long as you've stated that's what it means. So when does r of t equal h of t? You're looking for when they intersect. What? If you're going to use a separate function, you have to tell me what that function means. Yes. Come on. If you guys didn't do it, do it. What is the t values where this is true. T equals what? 4.790, is that the only one? 11.318. Okay, within that window, there might be more, but that's all we care about, right? Because it's only within that window. Now, we have to look at all critical points. What are other critical points? At endpoints, and when h of t minus r of t does not exist. Well, where does that happen? What was it? When does this function not exist? Why a negative? Because natural log of t plus 1, right? You can only take the natural log of what kind of numbers? Positive values. So t can't be what? Less than negative 1. Well, no, it's t plus 1. It's natural log of t plus 1. So it can't be less than negative 1, but that's outside the domain anyways, right? Because we're looking at 0 to 12. So that's it on the first one. What about the second one? That exists everywhere. So critical points are 0, 4.790, 11.318, and 12. You guys okay with that? Again, we're looking for the intersection of r of t and h of t. Now, how do I find out where the minimum is? Okay, if you're looking for when the value changes, or not the value, when this changes from negative to positive, you're finding a what? What kind of minimum? A relative. I want absolutes. So even if you have the relative, that doesn't mean it's necessarily the absolute. So what's the best way to go about it when you want absolute? You just plug all these in to figure out which one produces the least amount, right? So what equation would I plug these into to figure out the amount of oil? This guy, right? Because this is the amount of oil at what point? Part C said, how many gallons of heating oil are when t equals 12? So this is the amount of oil in the tank when t equals 12. So I'm going to do a chart here. I'm going to say amount of oil. We'll say when t, what do we get here? When t equals 0, 4.790, 11.318, and 12. We already know how many gallons are at 0, 125. And we already know what? At 12 is what? 122.026. How are we going to figure out these values? Plug them into what, though? To this equation. So this is going to be 125 plus the integral from 0 to what? 4.790 of h of t minus r of t dt. This is why you have these stored in your calculator. Because once you have this equation down from over there, the only thing you have to do is change that upper limit in your calculator. Go back to it, hit delete, and then re-enter it. Right? Okay. Anybody have an answer for that one? Into the home screen? You do 125 plus integral, and then y1 parentheses x, close parentheses, minus y2 parentheses x, close parentheses, then comma 0, comma 4.790, comma x, comma something like that, whatever it is. 149 point, what is it? 41? From 3 decimals. 408. I know I'm picky, but it's not because of me. Trust me. Yes? I don't know. Yes, it should. Thank you. Okay, so we got to do this one too. So it's going to be the same thing, just with a different upper limit. 0 to 11.318 of h of t minus r of t dt. So now that you have this one stored in your calculator, just scroll up and change that 4.790 to 11.318. What do you get? 120.738? Okay. So let's reread the question. At what time is the volume of heating oil in the tank the least? So, where's the least? Okay, so our answer is when T equals 11.318. Notice the question, at what time? It could have very easily said, what is the minimum amount, right? So in this case, it's at what time? So when T equals 11.318. You guys okay with that? You don't sound too good. All right, let's see how they graded this one. It's 3 points. So they set H of T minus R of T equal to 0. So you get 1 point for that. Or if you just said R of T equals H of T, they would have given you the point for that. So 1 point for the volume is the least at 11.318. And then 1 point for the analysis. So this is our analysis for the absolute minimum. If you strictly say it's because the rate changes from negative to positive, does that guarantee absolute minimum?
No.
It only guarantees relative. So you wouldn't have gotten the point for the analysis if that's your justification. You guys okay with this?